In class 10, you have read already ray optics to a great extent, and in class 12 there will be some extra topics. So we will mainly deal with the extra topics, but still then the elementary ideas have to be reviewed. So first thing is reflection of light. So what is the reflection of light? It is a phenomenon where a ray of light incident on a transparent medium backed by some denser medium like a plane mirror returns back to the same medium obeying certain laws called laws of reflection. So that is your reflection, and it has many applications. Reflection phenomena has many applications, like number one is object distance is equal to image distance. So that is proved by sighting method experiments. And second is left hand will appear as right hand. So how to verify it? Suppose you have a watch on the left hand, it will appear as right hand in the image. It will appear as right hand in the image. And third is, suppose you have a plane mirror and an object O. So this object will have an image I1 say. This is M1, M1 dash. First position of the plane mirror is M1, M1 dash. Then the second position, let us shift it. Let us shift it to this position. That is M2, M2 dash, M2, M2 dash. Suppose this displacement is x. Then the point is how much the image will be displaced. The image will be displaced by an amount 2x, which can be easily proved from this one. Object distance is image distance. So first is s, this is s, so it will be 2s. So OI1 will be 2s and OI2 will be 2 times of s plus x. So I2 I1 is equal to OI2 minus OI1, that is 2s. So this is one thing that and another thing is also, suppose you have a similar thing. Suppose there is a plane mirror M1, M1 dash, and there is an incident ray. Suppose the incident ray is AO. Then naturally this will be, say, angle of incidence is I. So angle of reflection will be also I. Suppose it is AOB. So AOB angle is equal to 2I, because it makes equal angle with the normal. That is your one of the laws of reflection. So keeping the incident ray fixed, suppose you rotate the plane mirror to the position M2 dash by an angle theta. Then what will happen? If the plane mirror is rotated, then the normal attached to the plane mirror will also be rotated. So, this will be, if it rotates like this, then the normal will be shifted. Normal will be shifted N2, and the angle of incidence will be decreased. So, if the plane mirror is rotated by theta, the normal also rotates by theta. Then the angle of incidence, this one, will be I minus theta. So, similarly, here will be the angle of reflection will be same, I minus theta. So, what will happen? You want BOC, that means how much the reflected ray is rotated. So, it will be BOC if you want, then you have to write AOB minus AOB minus AOC. So, it will be 2I minus 2 into I minus theta. So, it will be 2 theta. So, this shows that when a plane mirror is rotated by an angle theta, the reflected ray rotates by 2 theta. It is just like the third application. And another thing is the number of images formed by two plane mirrors kept inclined by an angle theta is here theta will be radian, because 2 pi is radian. If you don't want radian, then it will be 360 degree by theta degree. So, example is, suppose you have two plane mirrors and this is the object. So, this object should have 360 degree by 90 degree, that is 4 minus 1, 3. So, this image will be one of the images. Suppose this is M1, this is M2, then this is I1. Then the image formed by this M2 is your I2. Then what happens? This image is also makes another image, say here, that you can say is I12, and this image forms another image that is also formed there. So, it is I21. So, I12 and I21 they coincide. So, that is how you get 3 virtual images as expected. Similarly, if the plane mirrors will be parallel to each other, then theta is 0 degree, the number of images will be infinite. That is also there. Then another application is your size of the minimum size of the plane mirror necessary to view the entire body of a human being. So, sixth application is minimum size of a plane mirror required to view the entire body of a human being. Is 1/2 of the height of the man or woman. So, half of this is a ray diagram. So, from that it can be geometrically proved also. Then we go to the spherical mirrors. Usually we are accustomed to plane mirrors, but there are also spherical mirrors which can be prepared. Spherical mirrors which can be prepared out of thin hollow spheres by taking a circular aperture, circular cross section out of the spherical, thin hollow spherical. So, this is called the center of curvature and this is your pole. This point is called the pole. So, depending on the coating, opaque coating given to the transparent medium, there will be concave mirror and convex mirrors. Suppose you have a coating given to the concave side, then reflection will take place on the bulging part or convex part. So, this part is, this type of mirror is called convex mirror. And suppose you have the coating given like this, which is part of a sphere of center of curvature C and radius of curvature R. Then reflection will take place in the concave side. So, this type of thing is called concave mirror. Concave mirror. Then again this is also R, radius of curvature. So, here this type of convex mirror are found to have a virtual focus. So, what is the meaning of virtual focus? You have suppose parallel rays parallel to the principal axis. This is called principal axis that joins the pole and the center of curvature. This is principal axis. So, if a ray is parallel to the principal axis, then what will happen? It will be reflected. So, how it will be reflected? Suppose you join this point with the center of curvature and produce this way. So, this is your normal. So, this normal makes equal angle, the ray makes equal angle with the normal, and it will be reflected. So, it will appear to come from this point. Similarly, another ray, suppose you have second ray, and it will be in the same way. This angle may not be equal to this one. This is suppose I1, this normal is N1, then this is your I1, second ray. Then this will be focus. So this is called focus. So that means the parallel rays which are parallel to the principal axis, after reflection they diverge, they try to go away from each other, but when produced backwards they appear to come from a point on the principal axis. So this gives rise to a virtual focus. Virtual means there is no real existence, because you have extended it to get it, but still then it can be proved that this focal length, this is focal length f, focal length is half of the radius of curvature. It can be proved. Similarly, for the concave mirror also there is a focus. Concave mirror, there is a focus, and that focus is real focus, because you see, suppose this ray goes like this parallel to the principal axis, then as usual you can join with the center of curvature, and this angle is say I, and this will be I. This is your focus. And another ray, suppose you make this, that will also pass through the focus. So this gives rise to a real focus. Real focus. Then it is easily proved that R is nearly equal to 2f. In the NCERT book they have written R is equal to 2f, but that is not exactly correct, because as you see that this, suppose you give a name here M. So you see that this angle is also I. So therefore CMF is an isosceles triangle, is an isosceles triangle. So what will happen? The side lengths are equal, the CF. So this implies CF is equal to FM. CF is equal to FM. Then what is CP? CP is equal to small r is equal to CF plus FP, and this CF is equal to FM plus FP is your small f, that is focal length. So this FM will be nearly equal to FP, provided we take paraxial rays. Paraxial means near the principal axis. Paraxial rays. So if you take paraxial rays, then you can see that if a ray is nearer to the principal axis, then M will be nearer to P. So FM and FP will be equal. Otherwise, in this diagram it appears to be different. But then question is, why we will take paraxial rays? Because the plane this concave mirror and convex mirrors, those are used, have a limited size, they are not very big. So this, if the size is small, then only those rays which are nearer to the principal axis will be reflected. So, therefore, it is not unjustified to take this approximation. So, as a result, what will happen? R will be nearly equal to f plus f or nearly equal to 2f. So, that thing also applicable for convex mirror, that in the same way it can be done. Then the mirror equation. So, this derivation of the mirror equation was not in the 10th class course, but in the +2 it is there. Derivation of the mirror equation. Derivation of the mirror equation 1 by v plus 1 by u is equal to 1 by f. So, actually there are 3 derivations, because this concave mirror produces both real image and virtual image, but convex mirror always produces virtual image. So, what we will do? We will work out only one, because the time is limited. So, in the NCERT book there is a derivation for the real image by a concave mirror. So, let us try to find the mirror equation for the virtual image. So, this is your concave mirror, this is your pole, and so this is C, F. So, if the object is between F and P, this image formation is described in the class 10 in detail. So, I am not repeating it. So, suppose you have this AB, this is your object AB. So, the ray goes, one ray goes parallel to the principal axis, and after reflection it will pass through the focus. Then another one you can pass through the pole. So, if it is passed to the pole and it is normal, so it makes equal angle and it goes away from the normal second ray. Another ray can be passed also through the center of curvature, but by that the figure will be little bit clumsy. So, I am not doing that. So, there is a virtual image indicated by these slashed dots. So, this virtual image that is magnified. So, for this we want to find the mirror equation. Then you can see from this diagram, let us make it a M, and you can drop a perpendicular from M to on the principal axis, which is almost at P, but let us say it is P dash. So, let us drop a perpendicular from M on the principal axis. So, it is MP dash. So, from this what we do? we have to find two triangles which are similar to each other. So, if you take say M P dash F and so triangles M P dash F and B dash A dash F are similar. Why? Because three angles are identically equal. So, what are the three angles? One is 90 degree, another 90 degree. This angle is common and the rest and rest. So, if their angles are same, they are similar, and there will be sides will be proportional. Then sides will be proportional. Sides will be proportional. Then what will be, how much you will write? Suppose let us say bigger triangle first. So, B dash A dash by M P dash is equal to F A dash by F P dash, implies B dash A dash by M P dash is same thing as AB, or you can say BA as you like, and that is your F A dash. F A dash you can write as FP plus P A dash by FP dash. This is equation 1. Then we have to search two more triangles. We have to search two more triangles which will be similar. So, you can see from this figure that this angle is equal to this angle, because this angle is same as this one due to reflection, that is opposite to that. So, we have to search two triangles like B A P and B dash A dash P are similar on the same line. Three angles they are similar. 90 is there, this one is same and this one, rest is rest. So, the sides will be proportional. So, that implies what? What are the sides? Let us take first this one, B dash A dash by BA is equal to, this is P A dash by AP. So, from these equations 1 and 2, we see that the left hand sides are equal. So, the right hand sides will be also equal. Right hand sides will be equal. So, from equations 1 and 2, what you find that FP plus PA dash by FP dash is equal to PA dash by AP. This is a third equation. Then we use the same approximation, like say considering rays nearer to the principal axis, this point M will be closer to P, so that P dash will approach P. So, in that approximation for paraxial rays, you can say for paraxial rays M tends to P or approaches P, so that P dash approaches P, and this Fp dash will be actually Fp. So, equation 3 will become so then equation 3 will become Fp plus Pa dash by Fp is equal to Pa dash by Ap. So, now we will apply the sign convention. As you know from schools that it is a sign conventions differ from books to books, but the ultimate result is same. So, here the sign convention taken by NCERT is the object must be to the left of the mirror, so that rays will approach from left to right, and if all measurements are to be made from the pole of the mirror. So, if the measurement is from P to left hand side, it will be against the ray, so it will be negative. If it is along the direction of a ray of light, it will be positive. Upward it is positive, downward it is negative. Sometimes it is also called Cartesian system, because in coordinate geometry you know that left hand towards left it is negative, towards right it is positive, upward is positive, downward is negative. So, it is similar to that. So, using sign convention, comma, we get for this one Fp, the focus is real and you are measuring from P to F. So, it will be minus F, then plus Pa dash. Pa dash is image distance, and image distance is towards right, it is measured from P to A dash. So, it will be plus V, then Fp is there, it is minus F, and Pa dash will be V by Ap. Ap object is A, B. So, you are measuring against the direction of light Pa, so that is minus U. So, this will be minus cancels. So, minus Uf plus Uv is equal to Vf. Then dividing by UVF, comma, we get minus UF by UVF plus UV by UVF is equal to Vf by UVF. And what you find here? UF cancels, so it is minus 1 by V plus 1 by F is equal to minus 1 by U. So, if transpose to the other side, then you get this one. So, the next step will be 1 by V plus 1 by U. is equal to 1 by f. Then what we do? We have to find the magnification. Magnification, next work is magnification. Magnification is ratio between the size of the image to the size of the object. So, size of the image divided by size of the object. So, in this figure it is a dash b dash by ab, and it is written as h dash by h. Both heights are plus because this is measured upward, this is also measured upward. So, h dash by h. But if it is to be found in terms of v and u, then it will be minus v by u. Then one may question how you will get minus v by u, because from the equations that we have erased, you see that triangles BAP and B dash A dash B are similar. We have already done it. So, this B dash A dash by BA is equal to B dash A dash by BA is equal to P A dash by AP or PA something. So, from B dash A dash by BA is how much? H dash by H. And what is P A dash? P dash is V plus V according to sign convention towards right, and AP is minus U. So, this shows that M magnification is also minus V by U. It is H dash by H, but according to object distance, image distance, it is minus V by U. So, this is about the this one. Another derivation also you can work out for the convex mirror the same way. Then we go to the refraction. We go to the refraction of light. This is a phenomenon where a ray of light incident on a glass slab or water is found to bend towards the normal. On the other way, if the rays travel from water or glass, then they go away from the normal. So, this phenomenon is called refraction of light, and they obey two laws. One is the incident ray, refracted ray, normal, they lie in one plane. The important second law is called Snell's law. As per the scientist Snell, sin I by sin R is equal to n. N means refractive index, n or mu of medium 2 with respect to medium 1. So, it is like this. Suppose you have a glass slab, this is a normal, ray is incident. So, it bends towards the normal. So, it is incident ray, the refracted ray, and suppose this side is air, it is glass, and again there is air. So what will happen? Here you have to find another normal, and it goes like this. And it is found that if the two media are equal on the two sides of the denser medium, then the angle of emergence, I is angle of emergence, that is same as angle of incidence. And these are suppose it is A, B, C, D. So AB is your incident ray, then BC is the refracted ray, and CD is the emergent ray. And suppose you extend the incident ray, then it is found that the emergent ray is laterally shifted. That means sidewise it is shifted, and the amount of shifting is called L. So L is called the lateral shift, or sometimes lateral displacement. And this lateral shift can have an expression also. From this one you can see that this is angle I, so opposite angle is also I, so therefore this part is I minus R. So if you find sin I minus R, it is how much? It is L by the BC, L by BC. Then then cos R in this triangle BOC, from triangle BOC, cos R, you can see that it is BO by BC, and if you divide them, we get sin I minus R by cos R is equal to L by BO. If you write BO as the breadth or thickness, you can say this is like this. So that gives an expression for the lateral displacement. And here you find it is a complicated function, because accordingly if you change I, then R will change and lateral displacement will change, but thickness is fixed. So there is a experiment where if you plot different I in degree and L in centimeter, then it is found that the graph is like this. Why? The question is why this type of graph is obtained. From this one you can see that I, angle of incidence, can never be 90 degree. It will be less than 90 degree, suppose 85 degree or like that. But if you take the limiting case, in the limit I tending 90 degree, then L tends to T sin 90 minus R, that is cos R. Cos R cancelled, so you get T. That means this asymptote gives you the T thickness, and it will approach that because no one can exceed 90 degree. So the lateral displacement can have a maximum value of T, that is thickness. So this is about the little bit of elementary ideas of refraction. Then you come to this refractive index. So what is the refractive index? And there are two types of refractive indices. One is absolute refractive index and the other is relative refractive index. So, by definition, absolute refractive index n or mu symbol is equal to c by v. C by v means c is the speed of light in vacuum and v is the speed in the medium concerned. Like say, suppose you write N A, air, refractiveness of air, then C by V A, then N of glass, suppose it will be C by V G, and if you divide them, if you divide say N A by N G, what you get? That is Vg by Va, and if you invert it, then Ng by Na is equal to Va by Vg. So, this one is called the refractive index of glass Va by refractive glass with respect to air, and it is the reciprocal of that. It will be N, then final medium is your air and initial medium is glass. So, this you see that they are reciprocally related. So, Nag is equal to 1 by Nga. Example is N glass with respect to air is 1.5, that is 3 by 2. So, naturally Ag is equal to 1 by 3 by 2, that is 2 by 3, that is 0.666. This is the type. This shows that they are related, absolute and relative. So, it is called the relative RI. RI means refractive index of air with respect to glass. So, it is equal to relative refractive index of glass with respect to air. So, what you see from these things? How to remember these things? You see, the incident medium is air. If the incident medium is air and the final medium is glass, then it will be velocity of light in incident medium to the velocity of light in the denser medium. So, that is how we remember. The symbol is like this. So, then we come to the lens. From earlier times, people know the application of lens, because the sunlight was concentrated by using a convex lens, so that there will be production of fire. So, that thing people know from very earlier times, that you see lens. So, broadly there are two types, convex then concave. Concave or diverging, convex or converging. So, what is the definition of lens? So, lens is an optical medium. Lens is an optical medium bound by two surfaces. Bound by two surfaces. You see, so this is a convex lens. So, this is first surface which has a center of curvature C1. This is another surface of center of curvature C2. And if you join them, you get the principal axis. And this middle point of the lens is called the optical center. Optical center. Similarly, for the concave lens, the middle part is thinner and the outer parts are thicker. This is second surface, this first surface. So, here you see the center of curvature is C1 and it is C2. Here also you get the same thing. Principal axis. And this optical center is a point such that any ray that passes through it does not deviate. That means does not go away from each other. Then the question is, why the convex lens is called converging lens? Suppose you have a converging lens. This is a P, say, optical center. You can think that the convex lens is made out of many prisms. So, if you have a ray parallel to that, it will go towards the broader side. That is the property of the prism. We will discuss prism in the next class, and this is also found to go there, and this middle one goes on deviated because it is passes through the optical center. And in the same way you can have more rays. So, this is your real focus. Real focus is this one where all of them meet, and there is concentration of light there, and naturally PF is your focal length. PF is the focal length. But here what happens, if you divide it into smaller parts, the rays incident on one prism bends towards the broader side, so it goes in this way. So, if you produce them backward, they will try to come from this point F. The second one suppose comes here and it goes in the same way. Then the third one is not deviated, so the goes away like that. Diverges, and the fourth one also you can say that it diverges but tries to come from this one. So, this is a virtual focus because only by extension you are getting it, not actually the rays are meeting. And naturally this is also the focal length F, F to P is focal length. So, this is about the lens, and image formation by lens is also known from schools, where at various positions you get various images. So, the other thing which is not given in the NCERT book is the lens equation. Lens equation, just like mirror equation, it is 1 by V minus 1 by U is equal to 1 by F. So, derivation of the lens equation 1 by V minus 1 by U is equal to 1 by F. Just like say mirrors, it was 1 by V plus 1 by U, but here it is 1 by V minus 1 by U, and there are also three cases. Just like convex lens producing real image, convex lens producing virtual image, concave lens always producing virtual image. So, we can take one case and the other things can be done just like that. Suppose we take the concave lens case. It is a symmetric axis, and this is your P, optical center, and suppose there is a object here, AB. So, it forms virtual focus appears to come from that focus. Another thing, you can pass through the optical center, which goes undeviated. There is no deviation, no shifting. So, at the point of intersection, you have the virtual image A dash B dash. So, here you have to choose two triangles. So, triangles A B P, A B P and A dash B dash P are similar, because three angles are equal to three angles. So, the sides will be proportional. So, you have AB by A dash B dash is equal to AP by A dash P. So, this is one equation. Then you choose another triangle, two triangles with F, like suppose this point is L. So, LPF and B dash A dash F are similar. Similarly, just like three angles. So, what are the ratio? The ratio will be LP this side by B dash A dash by A dash B dash is same thing as FP by F A dash, or your LP is same thing as AB. So, it is AB by A dash B dash is equal to FP by what is FA dash? FA dash is FP minus A dash P. This is equation 2. So, comparing equations 1 and 2, left hand sides are equal. So, right hand sides are same. So, from equations 1 and 2, we get how much? AP by A dash P is equal to FP P minus A dash P. So, using sign convention, comma, we get what is AP? AP is your object distance and it is measured from P to A, so it is minus U. Then A dash P is image distance, it is also measured from P to A dash, so it is minus V. Then FP is measured from P to F, so it is minus F. Then minus F minus A dash P is minus V. So, it is now U by V is equal to minus F by V minus F. So, if you multiply, what you get? UV minus UF is equal to minus VF. Then as usual, dividing by UVF throughout, actually to all the parts, what you get? Dividing by UVF, you get UV by UVF is 1 by F, UF is 1 by V, it is minus 1 by U. So, what you get? You take this that side, then you get 1 by V minus 1 by U is equal to 1 by F. So, this is called the length equation. Then here also we can find the magnification. Magnification from these things. What is your magnification? Then how much you will get? Magnification is size of image by size of object. So, magnification M is your size of image is your A dash B dash by AB. Here both are positive upward, so it is H dash by H, and in terms of U and V we have to find it. So, for A dash B dash by AB you get equation 1. From equation 1 you get, from equation 1 comma, what you get? This is 1 by, this is H by H dash. So, it is H by H dash is equal to AP. AP is your minus U by A dash P is your minus V. So, it is U by V. So, implies M is equal to H dash by H is equal to V by U. So, here in case of mirrors it was minus V by U, but here it is V by U. So, this is for the concave lens. Similar things can be done for the convex lens for two positions, like the real image case and virtual image case. The results will be same.